Okay, a very good morning to all of you. Monica, you are there. So the QR code is not available. So Monica, you just take a screenshot of the attendance and send me, okay, after the class. So we should start. Okay. Monica, Suman there?
Yes, ma'am.
Audible now?
Yes, ma'am.
Okay. Okay. Next, today we will start with some statistical analysis. Okay. So, wait. So sit with your pen and copy. So under statistical analysis, what we are going to learn about standard deviation. Okay, important part. Many problems come from this particular standard deviation. So under statistical analysis, the most important is standard deviation. So the word is standard deviation, or you can say ST also. Okay, standard deviation. Okay, standard deviation. Now, under the standard deviation, this is a very important term in the analysis of random errors. Okay, we have learned random error, different types of errors under gross error, systematic error, random error. So, standard deviation actually a very important term in analysis of random error. So, it is related with random error. Okay, so random error, and it is, or you can say, so the most important term which is related in analysis of random error is the standard deviation, or you can say it is known as a root mean square deviation. Okay, or it can be also called as root mean square deviation, SQUARD, SQUARD. Okay, so it can also be called as root mean square deviation. So standard deviation, other name is root mean square. So standard deviation, you can say, of an infinite number of data is defined as a square root of the sum of the individual deviation squared. Okay, I'm repeating the definition again. Listen to me carefully. The standard deviation of an infinite number of data is defined as the square root of the sum of the individual deviation squared. Okay, divide by the number of readings. Because when I will write the equation, try to match it with the equation, whether it's it's matching with the definition or not. So I'm repeating the definition again. Standard.
मैम
Yes, बोलो राजकुमार.
मैम आपका आवाज बहुत इको हो रहा है, क्लियर नहीं है.
इको हो रहा है. इको हो रहा है.
यस मैम, लाइक कुछ बैकग्राउंड में जैसे कुछ चल रहा है.
अभी ठीक है? अभी फाइन?
यस मैम, फाइन.
फैन चल रहा था और कुछ नहीं. Okay, I'm repeating the definition again. The definition is standard deviation of an infinite number of a data is defined as a square root of the sum of the individual deviation squared, okay, divided by the number of readings. Okay, so if I try to write the equation for standard deviation, how I will write? I will write standard deviation, that is SD equal to this kind of sign I have put for a standard deviation to find it out. Okay, my equation will be just like this. See here, what you will write? I told you infinite number of data. square root of the sum of the individual deviations squared. So individual deviations I will take from D1 to Dn. Okay. So you see here D1 squared plus I can write D2 squared. Okay. Then I can write plus D3 square. I'm not writing dot dot dot. I'm giving plus I am writing here at last Dn square. This I can write. So this is the number of deviations. Sorry. This is the square root of the sum of the individual deviations squared. Okay. Divided by the number of readings. Suppose I have taken reading of n. Okay. This is my number of readings I have taken n. So if I try to concise this equation, then how I will do? I will just take the summation of this d of the deviations. That means we will put a summation sign here and then we will take a just a square of this d divided by n. Okay. So in many problems, you will see that you are requiring this formula to do. In many problems, you will be given the summation value of d. So you have to use this formula in those particular problems. Okay. So in practice, you can say, however, number of observations is finite. Okay. In observations, I have written dn square, but it's not possible that I have taken so many observations. In any problem, if you're asked to find out standard deviation, they will give you some 5 to 6 observations, right? So you have to do the addition of those particular observations. So when the number of observation is greater than 20, this is a very important note. When the number of observation is greater than 20, then the standard deviation is denoted by symbol this one. The symbol which I have drawn, this is the symbol. While if the number of deviations is less than 20, the symbol we will use S. Simple. So in this place, we can use S. So this thing keep in your mind that when the number of observations is greater than 20, then we are using this kind of symbol. And when the observations are less than 20, we are using only S. So we have also a formula for S. So that I will tell you. I'm moving on to the next page. Okay. So when our standard, first our equation that I wrote now, that is for infinite number of observations, okay, or you can say infinite number of data. Now, or you can say greater than 20 observations. That is why I have written this kind of symbol. Now I will move on to the next, that is standard deviation of a finite number. So let me do that. Of a finite number is given by S, okay, S equal to root over you have to take, and you have to again take the denominator numerator. So d1 square plus d2 square, okay, d2 square plus you can also write d3 square. I'm not writing, I'm writing up to dn. I don't know what will be the dn, but yes, it has to be less than 20. This I know. Okay. And in the numerator, you will take n minus 1. This is the difference between the two equations of the standard deviation, which is greater than 20 and less than 20. Okay. So n minus 1 I have taken. And if you concise this equation, then automatically you will get the summation sign of this d square, okay, divided by n minus 1. So this is my two equations for standard deviation. Another thing is important here, variance. Variance somehow same as standard deviation, but in that case, I'm showing you variance is a term which comes here with standard deviation VARIANC. So what is variance? Variance is the mean square deviation, which is same as standard deviation. So if I do the squaring of standard deviation, suppose SD, I know my standard deviation. So if I do the squaring of standard deviation, that becomes the variance. Okay. So generally in variance, we take greater than 20 observations. So we will keep the symbol like this. Okay. And we will put a square at the above of that. Then what will be the equation we can have? d1 square, right? d1 square, then d2 square, like that up to dn, up to dn. So here the dn will be greater than 20. So I'm not able to write here, you just write it divided by n. Okay, so variance I can obtain, that will be summation of d square upon n. Okay, so it will be just like this, summation of d square divided by n. So this is my variance for the observations greater than 20. Okay, now if I try to write the variance for the observations less than 20, then what will be the equation? Can you tell me the equation? Variance for observations less than 20? Anyone? Hello?
Yes, ma'am.
Yes, Rajkumar. Tell me are you able to understand? Variance batao. The less than 20 observation ke liye, what will be the equation?
Summation of d
D
square
square divided by n minus 1. Okay. So right now we have got 4 equations, right? From standard deviation, we got 2 equations. That is observations greater than 20, less than 20. And for variations, we have variance. Actually, we also got 2 equations, that is greater than 20, less than 20. Okay. So now we can do a problem. Okay, before going into the problem, let me tell you also the 2-3 things, that is average deviation and standard deviation I told you actually, and arithmetic mean formula, that is also important. Okay, another thing, because for solving a problem we require another thing that you keep in your mind is arithmetic mean. What is arithmetic mean? Now in your class 11-12 you already have learned arithmetic progression or all those things. So arithmetic, not arithmetic mean, sorry, wait. Arithmetic mean. We actually require this while solving any problem. Okay, so what is arithmetic mean? See, the most probable value of measured variable is the arithmetic mean of the number of readings taken. Okay, suppose I mean to say, suppose if I have taken x1, x2, x3, x4 up to xn readings, okay, that will be divided by n. N is the number of readings. Okay, so I have to take the arithmetic mean of all the observations I have done. That means for arithmetic mean, we can write x bar equals to from x1 plus x2 plus x3 dot up to xn. I will take the observations, okay, divided by n. That means what is x here? Here this x is the arithmetic mean, and this x1, x2 up to xn I have taken. These are the readings I have taken, or the samples I have taken, and this n is the number of reading. So in short, if I want to write, I can write that arithmetic mean is equal to summation sign of x divided by n. Okay, so in any problem, if you need to find out arithmetic mean, you will use this particular formula, that is summation of n divided by the number of the readings. Okay, so I hope I have made able to or make you understand. Okay, next we will learn we will be requiring that in case of doing problems, that is deviation. Yes, Rajkumar.
What is the difference between d and x here?
D and x, which one D?
D means the deviation.
Standard deviation.
Yes, ma'am.
No, see, nothing difference. I have taken different variables. Okay, जैसे कि अगर मैं देखो, if arithmetic mean, if I take D, then it will mix up, na? So to just pick the difference between the variables, observations I have taken x1, x2. अगर तुम चाहो तो x के साथ in place of x you can also take y, you can be anything you can take. Okay, it's just for make the difference I have taken x. This is the thing. And in standard deviation, the readings which I am taking D. That is just to make the difference in variables, nothing more than that. If you want, you can take different variables, not an issue. But the formula should be just like this. Okay. In place of this x here, I can also take z I can also take y. Okay, that won't make any difference. Next, we will move on to deviation. And in case of deviation, we are taking all the readings, all the variable samples as D, because deviation, what we are using. Okay, so the first word of deviation is D, that's why. So next is deviation. So here we will try to find out the average deviation, which we require in some of the problems. So let us see here. Deviation, you can say it is a departure of observed reading from the arithmetic mean of the group of readings. So suppose deviation of reading x1b. Deviation means what? We are deviating from the actual reading. Suppose our actual reading is 2. Okay, and our actual reading is 2, but somehow due to some error, the reading came 2.2. So what will be our deviation? 0.2 is our deviation. So in that case, we can write that deviation is a departure of the observed reading. I mean, the reading we are observing, okay, from the arithmetic mean of the group of readings. So if we consider, let the deviation of reading x1 be d1, okay, let the deviation of the reading x1 be equal to d1, and again for x2 be d2 like this. If we consider in this way, then what the equation we will be having? It will be just d1, that is the deviation for the first observation, that will be x1, okay, minus the arithmetic mean, okay, that will be x bar. That I told you what is the formula of this arithmetic mean. Just similarly, you can also have the same equation for D2. That will be x2 minus x. Okay, arithmetic mean will be same for all the deviations. So in this way, you can find out up to dn. Okay, up to dn you can find out. And if you are now asked to find out the sum of deviations, so how you will do sum of the deviations? You will just add all the deviations. That is, you will just add d1 plus d2, okay, plus d3, all these things. Sorry, wait. Okay, plus up to dn you will add, plus up to dn you will add, so you will get something. So what you will get, mainly you are about to get from this average deviation. If I told you that you will get somehow n is the number of the readings that you have taken, n x sub x bar, this kind of equation you can obtain. Okay, now if you're asked, this is the deviation and summation of deviation I told you. Now if you're asked to find out the average deviation, then what you will do? Average deviation is required. Now in average deviation is defined as the sum of the absolute values of the deviation divided by the number of readings. Okay, and what you will see here, the absolute value of deviation is the value without respect to its sign. So if we try to find out the average value of deviation, then what we can do? We can write like this, d bar, average value I'm writing, okay, that will be summation of d mod divided by n. Why mod I'm giving? Because if any negative sign comes, then you can place mod here. Okay, it won't consider any of the thing. That is why I have put here d. Okay, and this d value is stretching from d1 to dn, whatever be the readings. Okay, so try to keep remember all these equations, that average deviation means summation of mod of d divided by n. Okay, then arithmetic mean is a summation of x divided by n. Here d is the number of readings. There in arithmetic mean summation of x are the number of readings, just like that. Okay, and okay, so I have told you arithmetic mean, I have told you deviations from the deviations, I have told you average deviations, I have told you standard deviation, I have told you variance. Okay, so now we can proceed for a problem. Take down a problem. A circuit, electrical circuit, you can say, a circuit was tuned A circuit was tuned, T-U-N-E-D, a circuit was tuned for resonance by 8 different students. A circuit was tuned for resonance by 8 different students. Okay. And the value of resonant frequency in kilohertz are, a circuit was tuned for resonance by 8 different students, and the value of resonant frequency in kilohertz are recorded as, I'm writing the number here in the screen, do check it out. And the value of resonant frequency in kilohertz recorded as, first is 532, okay, first is 532, next is 548, okay, third is 543, okay, then fourth is 535, okay, then is 546, next is 531, how much, I don't know, 1 2 3 4 5 6, another 2 readings, 1 2 3 4 5 6, seventh one is 543, okay, and eighth one is 536. So these are the value of resonant frequency in kilohertz were recorded. Okay, these are the 8 numbers. Now you have to calculate number 1, arithmetic mean. Calculate arithmetic mean, first question. Second, deviations from the mean. Third, average deviation. Fourth question, standard deviation. And fifth question is variance. So there are 5 parts in this question. First, arithmetic mean. Second, deviations from the mean. Third, average deviation. Fourth, standard deviation. And fifth, variance. So what you have to do? You have to just apply the formulas. You know all the formulas, and one by one you will tell me the answer. And not only Rajkumar, everyone has to participate. These are sake of you people, not for me. Do the problem. I will ask one by one. Manorama, Ayushi, Priya, be ready with your answers. Here, Shika Manji, Shreya also, Shalini, everyone. Be ready with your answers. First is arithmetic mean you have to find out, right? So what is the formula you will use? Arithmetic is equal to summation of x, okay? Summation of x divided by n. So summation of x means you have to do the summation of all the 8 observations, that is 532 plus 548 plus 543, all these things, divided by how many readings are there? 8 readings are there, okay? So that you have to take 8 and you will tell me the answer in kilohertz. So tell me the value. Tell me the value of arithmetic mean first.
Ma'am.
Yes, tell me, Shalini.
Ma'am, 539.25.
Yes, 539.25 kilohertz. Don't forget to write the unit. That is important. Yes. So my arithmetic mean is 539.25 kilohertz. Okay, kilohertz. This is important. So this is my first part is completed, right? I will go to my next part of the question, that is the deviations. So for deviation, what I told you, the formulas you can use. That is, there are, yes, Rajkumar, tell me.
What was the answer of arithmetic mean?
539.25.
My answer is 538.87.
No, it's not possible. You have done something wrong? Calculation में कुछ गलत किया है. सिंपल एडिशन ही तो है. 8 जो तुम्हारे ऑब्जर्वेशन से उसको एडिशन करो, डिवाइडेड बाय 8 करो. सिंपल ही तो एडिशन है. फिर से एक बार करो, कुछ गलत किया होगा. 539.25 kilohertz. Okay. Then you see here there are 8 readings, right? So we have to find 8 deviations. Okay. So my first deviation, that is D1, the formula will be what? X1 minus arithmetic mean. X, this will be constant. So what will be my first deviation? I know my X1 is what? From the problem you see, my X1 is 532. Okay. So 532 minus what? What is my arithmetic mean? 539.25. Clear? So do the calculation part that I'm not doing, that you people will do. In this way, you will find 8 deviations. Means D1, D2, D3, D4, D5, D6, D7, D8. And you will all tell me the answer from D1 to D8. और अगर नेगेटिव में रिजल्ट आता है, don't get confused, it's correct. Okay, it's correct. So you all will tell me the, yes, Pooja.
What is
Yes, Pooja.
minus 7.25 kilohertz?
Yes, the first
D1 is
deviation
minus 7.2
yes,
kilohertz.
correct. First deviation is minus 7.25 kilohertz. Tell me the second deviation. Anybody else? Second deviation D2. कोई और बताओ. What will be the D2?
I'm 8.75.
Yes, plus 8.75. Plus 8.75 kilohertz. Okay. Then comes D3.
Ma'am, 3.75 kilo plus 3.75
yes.
kilohertz.
Yes, 3.75 kilohertz. Very good. Next comes D4. D4 क्या होगा? D4 का deviation देखो है 535. 535 minus with that arithmetic mean. What will be the answer?
Ma'am, minus 4.25
Minus
kilohertz.
4.25. Yes, very good. Minus 4.25 kilohertz. Next बताओ. Next batao, I'm going to the next page. Okay. D5. Tell me the value of D5. D6. D7.
6.75.
Yes, 6.75. Yes, correct. 6.75. Next, D6. D6. Jaldi.
Ma'am, minus 8.25 kilohertz.
Yes, minus 8.25 kilohertz. So that we have to mention the minus sign. D7.
Plus 3.75 kilohertz.
Yes, plus 3.75 kilohertz. Very good. Minus 8. Sorry, D8.
Ma'am,
D8.
minus 3.25 kilohertz.
Yes. So don't forget to write the kilohertz after these units. Okay. So ये हो गया मेरा B number. Second question my done. Deviations from the mean I have done. Okay. Then I will move on to my third question. You have to find out the average deviation. So what is the equation for average deviation? Average deviation was summation of mod of D, summation of mod of D divided by N. Okay, mod मैंने इसीलिए दिया था because in many you will get the negative value. Okay, so in this case we will not consider any negative value. So when you are doing mod, you will take all the values as positive. That means जो भी negative है उसको ही positive लेना है. So 7.25 plus 8.75 plus 3.75 plus 4.25 plus 6.75 plus 8.25 plus 3.75 plus 3.25. So see what is the addition coming? Divided by 8. 8 is the number of readings. Okay, so tell me the answer fast. This is the formula. Okay, you just do the addition and tell me the answer. So the signs of the deviations are disregarded here. Okay, this you have to keep in your mind.
Ma'am, 46 by 8 and answer is 5.7 kilohertz.
5.75, yes, 5.75 kilohertz. So this is my deviation, I mean average deviation. Okay, so let us move on to the next question. That is standard deviation you have to find out. Now you will tell me that which formula we will use here for standard deviation. Which formula you will use for standard deviation? I told you there are two formula for standard deviation. Which one you will use? Which one you will
Ma'am,
use?
for less than 20.
Less than 20, exactly. That means I will use the formula for S. Okay, so my formula will be simple summation of D square divided by n minus 1. So this is the, because I have only 8 readings in my question. Okay, so accordingly do that. So you just put the values of D, you know, from D1 to D8, you know the values. Okay, you just put it to the squaring and then niche hoga 8 minus 1. Okay, so 7.25 squaring of 7.25, 8.75 squaring of that. So everything you have to do it fast. Do the calculation and whatever you will get, then you have to find out the variance. The formula for variance will become S squared. So whatever S you will get, and that you will do the squaring, and so you will get the variance. So do the calculation for standard deviation. Root over भी है एक, तो उसको थोड़ा ध्यान में रखना. There is a root over also. Okay, there were 14 students, 2 students left out. कौन-कौन left out हुआ है? हाँ, आयुषी, मनोरमा, मोनिका, पूजा, राजकुमार, शालिनी, सुशीला, कौन-कौन लेफ्ट आउट हुआ है? तुम्हारा क्लास सोता है पूरा दिन? Out of 38 students, only 12 are present. Not 12, I'm excluding myself, then 11 are present. Good going. Exam ke time, you will face problem. Okay, tell me the answer of standard deviation. Understood now how you have to find out the standard deviation? D1 ka value you know, from D1 to D8 you know the values, do the squaring of the values, and then you have to do the root over. Okay, and divided by 8 minus 1, that means divided by 7. What is the answer? Taking a long time. Pooja? Hello? Pooja is not there?
Yes, ma'am.
Tell me the answer.
Ma'am, 6.57 kilohertz.
Okay, somehow 6.57, that means 6.57, okay. Jitna aa raha hai, I'm keeping that, okay. Then you have to find out the variance also. What is the formula of variance? S squared. So put it in the S, you know, S pata chal gaya. So just square the values. Rajkumar, standard deviation ka answer yahi aaya. Just check it out. Whether it's, what's your answer is coming.
नहीं बनाया मैम.
Okay. Pooja, what is the answer? Pooja,
Ma'am, 42.1 kilohertz
42.1 kilohertz. Yeah,
square.
yeah, near about it's correct. 42.1 kilohertz जो भी आ रहा है. See, the calculation, the process is this one. Okay, calculation part, you have to make sure that you do the correct calculation. Okay, otherwise the process is this, that यही formula use करना है और यही सब करना है. The process will be constant for any problem, this kind of problem. But the plus, minus, squaring, root over, this kind of things you have to look after. Okay. So this kind of questions are very common actually on standard deviation and all. Okay. Wait, if I got some other question. Okay, I have another question. So do I have time to dictate you? I think, wait, same question like this, you have to find out. Otherwise, I will post it in the group. So everybody has done now this question, not only Rajkumar and Pooja. Monica, Manorama, have you done this question? Ayushi?
Yes, ma'am.
अच्छा, अब किसी को कोई प्रॉब्लम है इस क्वेश्चन में? इस सारे जो आज मैंने कराया है, all this arithmetic mean, deviations and all, इसमें कोई इशू हो, कोई प्रॉब्लम हो तो tell me. Any issue, any problem, then tell me. Because this kind of problems actually come. Okay, and if you know the formula, na, then you can easily do it by yourself. No issues. Only the readings get changed and you can do it. Okay, then thank you so much for today's class. Monica, take the screenshot of the attendance and send it in my number. Okay, and the QR code is down. So if I get any other question, I will give you. You just practice it. Tomorrow, I think we have class now. So tomorrow we can